Hello everybody and welcome back to the second part of my particle effect tutorial series. In this part, I'm going to show you how to create a particle effect that moves between an infinite number of lines. This will be very similar to the previous version of the tutorial where I made a particle effect that moved in between two individual points. However, this one will be able to move in between an infinite number of points. Now, first thing first, I would like to show you a little bit of the math behind the code to give you a better idea about how this particle effect is actually going to work, just so that if you want to maybe change it a bit, or you actually are interested in learning how to create your own particle effects, that maybe will help you to do so. So if you're interested in doing that, we'll start on that next. Otherwise, go ahead and go to the timestamp on the screen now, and that will take you right to the part of the video where I show you how to complete the code. So here I created this diagram to hopefully help explain how this particle effect works. So you can see our particle effect moves from the first point to the second point to the third point to the fourth point to the fifth point to the sixth point. And now if you look at this, this is basically just a bunch of individual line segments. However, instead of like our previous tutorial where we're just playing one on repeat, we are moving from one segment to the next segment. So just think of it as we are doing the same thing as we did in the previous video, just instead of repeating the same line segment over and over. Once we reach the first point to the second point, we will be traveling from the second point to the third point. And then when we finally get to the last point, we're just going to be repeating back over to the very first point. And now at this point, the math is basically the exact same thing as it previously was. In order to find the x, y, and z positions of the particle we want to spawn, as just an example, I'm just going to show you with the x position, but basically you can just copy this same process for both the y and the z particle positions. So basically all we want to do is we want to get the first particle that we are spawning along our line, which will be index 0. And then we want to get the last particle we will be spawning along our line, which we will call index n-1, where n will just be the number of particles that are spawning along our line here, in this case 27 particles. So we're just going to go ahead and get that end location's x position and subtract the start location's x position, and that will get us this line right here. And then what we want to do is we want to get n, which is 27 particles. You can see the x location that all of the particles are going to be spawning at right here. And then what we're going to do is we're going to take the computation we took to get this entire line here and divide that by n, which in this case is 27 particles. And that gets us this little line right here, which is going to be the distance on the x-axis in between all of the particles spawned. So particle index 0 is going to be spawned right here at the x location of the start location. And then the second particle is going to be spawned at that same position, but we're going to add in this distance right here between particles. And same thing for all of these particles, and then finally, same thing with blue and green. And here you can see the formula to find the x position of any particle that will be spawned is going to be the x position of the starting location plus the end location's x position minus the starting location's x position divided by 27. And then we'll multiply that by the index of the particle that we are spawning. And so here you can see this particle is index 0, 1, 2, 3, so on and so forth until we get to n-3, n-2, and n-1, which is basically just 26, 25, 24. And if you're wondering why this is n-1 and not n, that is because the first index is index 0, not index 1. So this last one is going to be index n-1, not index n. So you can go ahead and just take this equation right here and just fill it in for all whatever particles we want to spawn here. And now that we have that, we can just go ahead and hop right into the code. So here we are in IntelliJ. Now I am going to be creating my particle effect in this run effect method. So in your project, you can go ahead and copy the code I write in here and just paste it wherever you need it in your own program. I also created this program for myself. For these properties are just going to be an integer called speed, and this will just be the speed our particle is moving. The smaller the number, the faster the particle will move. Now next up, I'm going to be creating a double, and I'm just going to call it dist between particles. And I'm just going to set this to be 0.25. This is basically just going to be, I misspelled particles there. This is just going to be the distance in blocks between all of the particles that spawn. So if you want the particles to be closer together to look more like a line, you can make this number smaller, or if you want it to be more spread out, you can make it bigger, up to you. Now finally, I just want to create an array list containing locations, and I'm just going to call this particle locations. And I'm going to be setting this equal to a method that I am going to be creating in a second called getParticleLocations. And I'm going to be passing into this method that we're going to be creating the dist between particles. And now basically this is just going to make it so that we will store all of the particle locations for our particle effect in advance. And this just saves us so that we don't have to be doing as much computational power throughout the entire existence of our particle effect. Now I'm just going to be creating our new method down here. It's just going to be a private method, and it's going to return an array list of locations. And we're just going to call it getParticleLocations, and we're going to pass in a double, and we'll call it dist between particles. Okay, now within this method, there's a few things that we are going to be wanting to do in here. First off, we're just going to create some variables here. We'll create an array list of locations, and we'll just call it particle locations. And we'll set that equal to a new array list. New array list. There we go. And then we'll be creating a double array, and we'll call it distances. And we'll set that equal to new double, and we want the length to be points. And now keep in mind, points is just a list of locations. These are the points I want my particle effect to move between. So just whatever container of locations you have yourself, you'll just want to use that in exchange of what I use points as. So yeah, just up here you can see points is just an array of locations in order that I want my particle effect to move in between. And we're just going to set that distances array to be equal to points.size -1. Now finally, we're also going to create a double, and it'll be called total distance, and it'll be set to 0 initially. Make sure you spell total right. Okay, now that we have these variables here, what we want to do is we want to compute the length of all of our line segments. So with this, basically, as I showed you in the diagram earlier, basically we just want to figure out the length of every individual segment. So we're just going to create a for loop here, call int I equals 0, while I is less than distances dot length, and then I plus plus. Now in here, what we want to do is we want to set the distance for this particular line segment, and what that will be is it is just points dot get I dot distance. Dot distance of points dot get I plus 1. Okay, and that will be the distance of that particular line segment. And now we just want to add that to our total distance. So total distance plus equals distances index I. Okay, there we go. Now we have computed the length of all of the line segments. And now that we have all of those lengths, what we want to do is actually compute the distance between particles in every segment. Okay, and so to do this, what we want to do is we want to create a for loop. Just be int, we'll call it segment, set it equal to 0 initially, and then we'll segment is less than distances dot length, and then segment plus plus. Okay, now in here, the first thing that we want to do is we want to compute the distance between particles in segment. So this is basically just the same thing we did in the previous tutorial with a simple single line, and also what I showed you in the diagram earlier. So to do this, all we have to do is first just find the particles in segment, so the number of particles that will be inside of this individual segment. And we're just going to be setting that equal to math.max. And then the first thing that we're going to be putting in here is going to just be math.round. And we'll be giving that distances segment and divide that by the dist between particles. And then for the second thing that we want to get the max of these two variables between, we'll give it 1. And then our semicolon, you want to make sure that you cast this to an int. And then basically what this does is we get the rounded distance of this segment divided by the distance between particles. And this tells us the number of particles that will be inside of this segment. And then we just round that to make that as accurate as possible. And then we also want to get the max between that number and 1, just so that we ensure we have at least one particle that will be spawning in this segment. And now that we have that, we can actually compute the distance between particles on the x, y, and z axis. So all we have to do for this is just create a double, call it xdist, and we'll set that equal to points dot get segment plus 1 dot get x, and then we'll subtract points dot get segment dot get x, and then we'll take all of that and divide it by particles in segment. And then basically this just does exactly what I showed you in the diagram earlier. And now we basically just want to do the exact same thing for our y and our z distances. So I'm going to just go ahead and copy and paste those. And now we want to make sure we replace these x's with y's here. Y, y. And then same thing with our z. Replace that with z, z, z. Now just double check that all of the x's are replaced with y's and z's. So we got y, 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 then z, z, z. This is a common place where errors can pop up, so it's good to just double check. And now that we have these distances between particles in each axis, we can actually compute the particle locations in segment. Okay, and so all we have to do for this is we just want to create a for loop, create int points equals, or just call it point equals 0, while point is less than particles in segment, point plus plus. Now in here, we're going to actually compute the x, y, and z positions we're going to be spawning this particular particle in the segment. So for this, all we have to do is double x equals points dot get segment dot get x, and then we will add that x distance and multiply that by point. Now same thing with y and z. I'm just going to, for simplicity, copy this over, replace the x with y, y, and y. Make sure you do it in all 3 of these locations here. Z, get z, and zdist. Make sure we replaced all of our x's with y's and z's in the correct location. Very good. Now that we have that, we can simply just add this particle to our list of particle locations. And all we have to do for that is just particle locations dot add. We want to create a new location. and then we'll just give it points dot get 0 dot get world, easiest way to get the world instance. Then we just give it x, y, and z. Nice and easy, very simple. Now we'll just let that loop finish up computing the particle locations in every segment. And then at the end here, we're just going to return particle locations. And then that is all we have to do for this method. And here we officially have the particle locations for all of the particles we're going to be spawning. And so now the easier part, just spawning all of the particles. So here, just spawn particles. So we're going to be creating a bucket runnable here, of course, to create our repeating task. So all we have to do for that is just create a new bucket runnable. And then at the end here, after our curly brackets, we're just going to do .run task timer. And then the first parameter you want to pass in is your Java plugin instance. For me, that is _plugin. Then the second thing that you are going to give it will be the delay. We just want that to be 0 because we want our particle effect to start instantly after we start playing it. And then finally will be the distance, or the amount of time in ticks between particles spawning. And so for this is where we just use our speed variable here. Okay, very good. And now just one more thing that I personally like to do is I have a integer up here I created called int task ID. I just do this to keep track of the task ID of this repeating task, because in order to cancel this repeating task so your particle effect stops playing in the future, you have to pass in this particular task ID. So just to kind of allow me to do that and make it simpler for me, I just go ahead and assign that here. So I just do _ task ID, and then I set that task ID equal to this here. And finally, we actually want to get the task ID to assign to our task ID. So at the end of this run task timer here, we just want to do .get task ID. Now this is optional, of course, for you. I just like to do this because I like to cancel my particle effect at a particular time, and I have that functionality included in my project, so it's good for me to keep track of it, but it's up to you if you need that or not. Now, here, our bucket runnable needs the run method, so I'm just going to have IntelliJ create that for me automatically. Okay, now that we have our run method here, in here, outside of our run method within our bucket runnable block here, we're just going to create an integer and call it IDX for index, and we'll set that equal to 0. And this just keeps track of the index of what particle we are currently spawning in our particle locations array. And now within our run method, all we have to do first is just, we want to update the IDX. And so for this, all we have to do is if ++IDX is greater than or equal to particle locations dot size. And if that is true, all we have to do is set our index equal to 0. And basically all this does is it will increment our index every time we spawn our particle. And then it'll check that if our incremented index is greater than the actual number of particles that we have to spawn, it'll just set it back to index 0. And this just makes it so our particle effect links over and over and over again. Alternatively, if you really wanted, you could just stop your particle effect right here if you only wanted it to play down your line once. But that's not the effect I want, so this is what I am going with. Okay, and now that we have our updated index, above that, I actually want to spawn in our particles. So I'm just going to spawn particles here. And now, very simple for this, I'm just going to get $x, going to get the x position of the particle we want to spawn. Just set that equal to particle locations dot get IDX dot get x. Then same thing with y and z, y equals particle locations dot get IDX dot get y. And then z equals particle locations dot get IDX dot get z. And now that we have the x, y, and z position of where we want to spawn our particle, all we have to do is actually spawn in our particle. So for this, all we have to do is particle locations dot get 0 dot get world, just because we need the world instance in order to spawn our particle in the world. Then we'll just do dot spawn particle. And now the first thing you pass in is just the particle you want to spawn. I'm going to spawn in the particle I showed in the example earlier, which is just particle.composter. Then we're just going to pass in the x, y, and z positions that we want to spawn the particle at. So just x, y, and z. And then we want to give it the number of particles we want to spawn. And then optionally, you can give it the offset for where the particle will spawn, which basically just means that you give it a range of where the particle can actually spawn. So if you give it like 0.5, it can spawn either 0.5 blocks above, below, left, or right of where the particle location actually is, but we want it to spawn exactly where we're telling it to, so we'll just give it 0, 0, 0 for the offset, or you could just leave that blank. It's an optional set of parameters. And just to make it look exactly like how I had it in the example, I'm also going to add in some decorative particles here. So one of those is just going to be a crimson spore, and then a second one is going to be falling obsidian tear. And now these ones, I actually do want to give them a little bit of an offset, just because it kind of makes it look a little cooler to have it not directly on where the particle spawns. So I'm just going to set that offset to be 0.5, 0.5, 0.5. And same thing with the falling obsidian tear particle, 0.5, 0.5, and 0.5. And now here, this is all of the code we need for our particle effect, and now we can actually hop into Minecraft and check out what our particle looks like. And also, if you want to add in any of the extra special effects I did in the previous video, you basically will just do it the exact same way in that one. The only difference is that we are not computing the x, y, and z distances in our run method. That already happens within our get particle locations. But basically, you're just going to be encapsulating practically the same things within whatever for loop or updating the index or whatever effects you want. Basically, it's just going to be the exact same thing. It's just you aren't going to be including the x, y, and z distances here. And if you need any more help with that, just go ahead and leave a comment in the description below. And as soon as I see your comment, I will get back to you and I will help create a little snippet of code for you to do that effect if you are having a hard time doing it yourself, because I am always happy to help out. So here we are within our server. Now we can go ahead and test out our particle effect. And with mine, as I said in the code part of the video, I created this command so I could just type in /cpe and then the name of the particle effect, which is just multi-line. And then I can just enter that in and put it at all of the positions I want. And you can see here it is already starting to work as I give it more and more points. So I can just go ahead and add in all of my points here. Very good. Just add in all of my points. And for good measure, let's put one up in the air so you can see it working in the y-axis as well. And then here, finally, you can see we have our finished particle effect, which is very nicely moving between all of the points that we gave it. Now, I will be uploading all of this code to GitHub, so if you have any issues or you want to check it out in more detail, you can look at my code there. And then if you still have issues after looking at that, you can go ahead and leave a comment below, and I will get back to you as soon as I see it. And if possible, please include your code in your comment, or maybe put it on Pastebin or something like that, just because that'll help me kind of debug your code and get a better idea about what could actually be wrong. So I hope you found this tutorial helpful. In the next one, I will be showing you how to create the curved particle effect, and I promise that video will not take as long as this one did because it's already in the works. I already got the code for it, and I'm already working on the diagrams for it. So with that, thank you very much for watching. I hope to see you in the next video. If you have any other particle effects that you would like me to show you how to do, if there's any ideas you have for a particle effect, or If there's maybe a particle effect you've seen somewhere on another server or something that you would like me to try and replicate, I would be happy to do that. I always love hearing your ideas. I love seeing your positive feedback. It is the whole reason that I even created this tutorial video, because I was kind of falling out of my enjoyment for creating these videos, but all of the feedback has been very positive, and it's made me feel very happy, and I love seeing all of your comments and interacting with you and speaking with you. So just let me know if there's anything you would like to see or anything I could improve in the comments below. I hope to see you in the next video. Goodbye.